Hello everyone, I'm Rajesh Kumar, team leader of Team X, representing HACKATHON University, Pune, Maharashtra. Our team members are Aryan Sharma, Abhay Chauhan, Raj Pandey, and Bhavya Rani. We are working under the guidance of our mentor, Dr. Rohini Vijay Tarade, for the SAMVED 2026 Hackathon. We have selected the problem statement titled Smart Safety and Assistance System for Sanitation Workers of Solapur Municipal Corporation. Through this project, we aim to redesign how manhole safety is managed, shifting from reactive practice to predictive, AI-driven and enforced protection system. Before we explain our solution, I wanted to show you something. This news report shows that 4 sanitation workers died while cleaning a drainage in Solapur. They entered the manhole one after another. Within minutes, they inhaled poisonous gas and lost their lives. This is not an isolated incident. This is a recurring pattern in manhole sewer operations. Sanitation workers operate inside confined space where atmospheric conditions change rapidly and unpredictably. Toxic gases like hydrogen sulfide, methane, carbon monoxide, and oxygen deficiency can build up silently. At the same time, water level can rise suddenly and structural instability can occur. The current safety system is mostly reactive. Handheld gas detectors only alert after a limit is already breached. These decisions are left to manual judgment. There is no predictive modeling, no probabilistic risk estimations, no enforceable digital control system. The major technical gap are no time series forecasting of hazards, no multi-sensor uncertainty modeling, no flood or black flow prediction, no confidence-based automated design mechanism, and no structured digital accountability framework. Because of this, hazard detection happens after dangerous conditions have already formed. Workers are exposed to life-threatening gases. Emergency response is delayed, accountability is weak. So the core engineering problem becomes very clear. How do we design a predictive AI-driven safety system that can detect hazardous environmental conditions before threshold breach? The enforced probabilistic confidence aware entry control under realistic municipal constraints. Our goal is not just monitoring, our goal is to prevent unsafe entry completely. So, our solution is basically designed to change how manhole safety is handled. Right now, what happens is workers go inside and safety devices mostly react only after something becomes dangerous. What we wanted to change that, instead of reacting after the limit is crossed, our system tries to predict the danger before it actually becomes critical. The way it works is in very simple 5 stages. First scanning, then analyze, then predict, then decide, and then protect. First, we collect environmental data safely without opening the manhole directly. That means no direct exposure in the beginning. But the important part is we don't just look at the gas value and check, okay, it crossed the limit. We look at trends like, is the gas rising fast? Is water level slowly increasing? Are multiple gases changing together? So instead of a single number, we study the behavior over time. Then comes the AI part. Our system actually tries to forecast what might happen in the next couple of minutes. It predicts gas concentrations ahead of time. It also checks if something unusual is happening that doesn't match in normal patterns. After combining all this, it calculates a risk probability, not just safe or unsafe, but a probability. Based on that probability, the conditions becomes green, yellow, or red. And there is an important difference. The entry decision is not manual anymore. If the system says risk is too high, the entry stays logged. No guessing, no emotional decisions. And if entry is allowed, monitoring continues. The system keeps recalculating risk every moment. If suddenly gas spikes or water rises fast or something abnormal happens, it automatically switches to red and triggers evacuation. No waiting for someone to press a button. And also, every operation is recorded. Every time, every environmental data, risk scores, decision taken. So over time, authorities can see which locations are high risk and improving planning. So in simple words, our system moves manhole safety from reactive detection to predictive and enforced protection. It protects workers before danger forms and makes safety decisions structured, data driven, and accountable. I will briefly explain the hardware part of our system, which we will call Smart Manhole Safety Scanner. The entire hardware is built on one main idea: zero open entry inspection. Before any worker goes inside a manhole, a detachable probe is inserted through a small sealed inspection port without fully opening the lid. This means the worker is not directly exposed during the first safety check. The probe contains multiple gas sensors that can detect hydrogen sulfide, methane, carbon monoxide, and oxygen level. Along with the gas detection, the device also measures temperature, humidity, sewage water level using an ultrasonic sensor, and structural vibration using a vibration sensor. There is also a built-in camera that helps usually check for blockage, cracks, or harmful animals. All sensors data is collected once every second and processed locally using an ESP32 based controller. The device performs basic data cleaning and preparation before sending it to the AI risk engine. The system includes a dual safety lock mechanism, both mechanical and electrical. This ensures that scanning only works when the probe is properly connected and sealed. One of the front of the device, an RGB light shows that the safety status. Green means safe, yellow means caution, and red means dangerous. A buzzer and vibration motor gives emergency alerts even if there is no mobile connection. The device runs on a rechargeable lithium-ion battery that supports more than 8 hours of continuous use. The outer body is strong, water resistant, and built to handle dirty and corrosive severe environments. In simple words, this hardware acts as a physical safety layer of our digital safety gate. It prevents unsafe entry and allows environmental conditions to be verified before any worker is exposed to the danger. I will explain the software and the application layer of our system. This is the intelligence and the control center of the safety gate. Our system is not just a sensor dashboard, it is an AI-based safety platform that connects hardware, mobile apps, supervisors, SMS alerts, and a central monitoring system into one enforceable safety network. The software works through multiple connected parts: data collection, AI analysis, digital entry control, continuous monitoring, and emergency alerts, logging systems, and a supervisor dashboard. First, the Digital Safety Gate app. Manhole entry is controlled digitally. Entry is allowed only when the risk probability is less than 20% and the model confidence is 90% or more. These safety rules are fixed and cannot be edited. Even supervisor cannot casually override them. Any override must be justified and permanently recorded. Second, the real-time risk display. The app continuously shows gas level, oxygen level, water height, temperature and humidity, structural vibration. All the data is converted into one clear risk score app, where the app will show green for the safe, yellow for the warning, red for the dangerous, unlike normal devices that reacts after limit breach. Our system predicts risk before it becomes critical. The third one is safe working time calculation. Even when entry is allowed, the app shows entry time and safe time remaining. If the gas suddenly increases, water rises fast, or sensor data stops for more than 5 seconds, the system automatically switches to red and triggers evacuation. No manual approval required. Now briefly about the impact and the feasibility of our system. This solution directly protects sanitation workers from toxic gases, sudden flooding, and unsafe entry decisions. Instead of reacting after damage happens, our system predicts risk in advance and enforces safety automatically. This reduces feasibility, prevents long-term health damage, and improves dignity and the trust in municipal operations. From a feasibility point of view, our hardware uses affordable and locally available components. This system is battery operated, works in offline mode, and is designed for real municipal conditions like humidity, heat, and poor connectivity. The AI model are optimized to run on edge devices like ESP32, making the system practical and scalable for the city-wide deployment. Over time, collected data can help authorities identify high-risk manholes and plan preventive maintenance. In conclusion, our system transforms manhole safety from manual judgment to predictive, automated, and accountable protection. Thank you for your time and consideration.